So today you'll be working on the volume of prisms and cylinders. A couple of basic ideas that you need if you recall from doing this before. To find the volume of a prism or a cylinder, basically the formula, volume's going to be the area of the base times the height. So what we mean is you find the area of the base of the figure and then you multiply it by its height. Now the base is going to be the faces that were parallel. So if you think about that, when we talked about prisms, there was, you had two sides that were parallel, and then in between there, they were connected. It was, by usually rectangles, sometimes other shapes, in the case of a cylinder. So what we're going to do is go through a couple of problems. You should have your worksheet now. On the bottom right, it says 12.4 volumes of prisms and cylinders. And we're going to do a couple of examples, and then you'll have some time to work on that. So first thing we're going to start with is number 4. When you look at this figure, there's really no exact way to do this. What we kind of need to do is we're supposed to find the volume of the solid by determining how many unit cubes are contained in the solid. I mean, that's really just finding the volume. So what we have to do is break this into parts. Now you may say, well, I could draw a line there, or I can draw a line here. Either way, what you need to do is just break it up in some way. So we'll stick with this shape. You notice your prism right here, in this case, that you have, it's a rectangular prism. So if you think about the shape we have, all right, so if I just sketch it over again, off to the side here, stand alone, it would look like this. Now, what do I have for dimensions? Well, this part's 2, its height is 5, and then we have this measurement's 1. So we have to find our volume is going to be the area of the base times the height. Well, the base in this case is a rectangle. So volume, area of the base, how do you find the area of a rectangle? Length times width. So 2 times 1 times the height of 5. Multiply those together, you get 10. So what we have, and that's units cubed, if you recall. You've seen this before. So then we do the second part. So you might, again, look at that shape and realize it's, again, a prism, a rectangular prism. Your measurements are 1, 2, and across the bottom here, you might want to think, how long is this piece right in here? Well, the whole thing all the way across is 7. This little section right here was 2. So that means 7 minus 2, it's 5. So volume, area of the base times the height, the base again. Now in this case it's 5 and 1, so we have 5 times 1 times 2. So again it's 10 units cubed. So our total volume in this case, volume is going to be 10 plus 10, or 20 units cubed. So that would be number 4, one way to do it. Also, if we take a look now at number 7, one key here is, the formula is always volume equals area of the base times the height. Well, in this case, the base has to be the parts that are parallel, right? You notice you have a triangle here and again on the bottom. So those are your two bases. Well, how do you find the area of a triangle? The triangle, again, if you look at your green sheet, base times height divided by 2 for the triangle, its area. So we have our base and our height, the 7 and the 10. So we have 7 times 10 divided by 2, and then we're going to multiply that by the height of this prism. Well, here's our height of 5. So you'll take your calculator and then, do those things, work it out. Take 7 times 10, get that number, divide it by 2, and then multiply by 5. So 175. So that is our volume. And in this case, it's given in inches, so it's inches cubed. Now again, if I go too fast or parts of this are unclear and you want to rewind it, feel free to do so. The last problem we're going to work today is look at a problem like number 18 on your page. So again, you're writing this down somewhere. This one, it says, calls it a composite. So it's really not just one, it's a couple figures together. In this case, what we have is a cylinder, and then the cylinder has a hole cut in it. So what we want to do first is, to find the area of the big cylinder. So we're going to take the area of the whole thing of the large cylinder, and then subtract off area that's cut out. So that's kind of the plan here. You find the area of the whole thing, and then if there's part of it cut away, find out how much that is and subtract it off. So if we take a look at this now, what we're looking at is the first one, the big cylinder. So we're going to start with that. So the large one. So the large cylinder, we're going to kind of look at that now. Well, same volume as area of the base times the height. Well, the base in this case is a circle. Those are the parts that are going to be, what do you want to call it, parallel to each other. So the volume, the base is a circle from your notes. The area of a circle, pi r squared. And then we're going to take that times the height. Now, so in this case, our radius is 3. And our height is 7. So we're going to leave this in terms of pi. We want to get an exact answer if we can. So you do 3 squared, you get 9 times 7. So then you have, that is 63 pi. Okay, so that's the big part. Now we're just going to find the volume of the one that we're cutting out. So that volume, again, it's area of the base times the height. The base, again, is a circle, pi r squared times h. Now the radius of the small one is only 1. Height is still 5. So when we multiply this out, 1 squared is 1, multiplied by 5, we get 5 pi. Just as we said we would do in the beginning, we're going to take the large one minus the smaller, so we take 63 pi. And then we're going to subtract off 5 pi. So the volume is just 58 pi. And that should be meters cubed. I left off that unit in this. I should have had meters cubed here as well. But so that would be how you could do number 18. So then I would like you to continue to work on that sheet for the remainder of today. The ones I'd like you to do would be 5, and then basically you have 5 through 8. We already did number 7. And then I would like you to also do, in this case, work on 10 through 13. Now, what I'm going to ask you to do is finish and actually do 19 and 20. So then you go to the back side of your paper. There are a couple different problems here I'd like you to try also. 21, 22, and then 28 on the back, and 29. So if you do those for the next day. If you want to check these or to check them, the Teacher's Edition has a bookmark in it, and you should be able to check those in there.